So my name is Jarek. I work for Red Hat for 7 years now. I started in UK. Then we started team here in Poland. So I moved to Warsaw, and I work now from Poland, mostly with let's say Central Eastern Europe customers. In this presentation, I will share with you our experience from building and deploying applications which were deployed in a multi-cloud or hybrid cloud architectures. Actually, this kind of practice, which is focused on actually, the practice was initially focused on a hybrid cloud deployment. We started that practice around 5 years ago. At the time, 5 years ago, it was a time when there was a first release of Kubernetes. And we as second largest contributor of Kubernetes, just I think few weeks before Kubernetes 1.0 released, we released our OpenShift, which is based on Kubernetes. And this technology was pretty much the foundation for offering to the customers hybrid cloud implementations. And because within these 5 years, many customers also started moving to public or multi-clouds, we also extended this this program and this offering to multi-cloud, and this is where we are now. There is a lot of people here, but I will try to ask you: who of you is developers? Okay, most of you. And who of you are operators, administrators? Okay, nice. And some architects, maybe? Okay, cool. So there are two sections in this presentation. So first part will be more for developers. The other one will be more for administrators, but I think it's also interesting for developers. This will be very short, so I will touch very briefly those topics. But this is based on our real-life experience. So we have implemented, I know, a few dozens of this kind of projects where we, where the goal was to deploy the application in hybrid or multi-cloud. So there are many good reasons why customers want to deploy applications in multi or hybrid cloud. Typically, when you will start, or you will start, or you have started your journey towards public cloud, you will start with some kind of hybrid cloud approach. So you will have some applications running locally, some in your private cloud, some or your data center, and some will be moved to public cloud. For many customers, this will be also the end of the journey, at least for some time, because of some legal issues, some data privacy issues, or some other reasons. And this is basically our, I would say, typical environment. So I would say 99% of projects we deliver, they have some part, bigger or smaller, which is deployed in private cloud, and is somehow expanded to the public cloud. So there are a couple of common topologies or architectures for the applications that we have seen over the time. So typically the most basic and typically the scenario where customers are starting is to run non-production environments in public cloud and then and run production in private cloud. So this is not really kind of hybrid or multi-cloud approach I will be focusing on, but this is typically what customers are doing, and this is also quite good way to learn and practice how to implement platforms that spans multiple clouds. There are much more interesting use cases. So geo distribution. This happens typically when customer is building some global system. So they want to serve customers in Europe, Asia, United States. So they want to have the application distributed between different data centers, public clouds, or regions from a single cloud vendor that are geo-distributed. Another quite interesting example is when you have some application running in your private cloud, typically in your own data center, and you want to scale it to public cloud to handle some peak. And there are a couple of good examples, so retail and banking, so you probably have heard today some of them. And another also quite interesting use case is when you have a large application, but you create some layers. So typically data-related layers, so databases and some business logic that is very data-oriented is running in your private data center, and there are some front ends, maybe some APIs that are deployed to the cloud, and they communicate via some internal APIs with the backends. And these are the most typical use cases that we used to implement within the last 5 years. Okay, so let's start with some basic about the application. So probably no surprise, but we are talking here about the applications that were containerized. So the containerization was always the first step to make those applications, let's say, multi-cloud or hybrid cloud ready. So we have a process where first we are doing some kind of assessments over the application portfolio that customer has, and we select the applications we want to migrate. And there are three major strategies to. Sorry, it was me. Two major strategies to containerize the applications. And then, of course, some customers will start developing some new applications which are cloud native, and they want to deploy them natively in the cloud. So for existing workloads, there are three strategies we use. So first one, rehost. This is basically where we just containerize the application. Of course, this typically requires that the technology that has been used to build the application is somehow easy to containerize, because we assume we can do it very quickly. So it's lift and shift approach. And then having the containerized components, layers of the application, because this is typically the scenario for not necessarily microservices based architecture, but more for legacy. So sometimes three-tier, sometimes three-layer, sometimes multi-layer applications. The second approach is called replatform, and in this scenario, we decide that we don't want to change the existing application. So basically, we let's say we freeze the current application, and we decide that all the new services will be built using will be containerized and will be built using the containerized technology. So as you can see, this typically requires building some integration layer between the old part of the application and between the new services. But this for some topologies of the application, this works pretty well, and of course for some use case. And there is a third approach, the most time-consuming and the most costly, typically. So we decide that we want to completely rewrite the application, and we modernize the application, and we containerize it. Quite often we change the architecture from monolith to microservices. Again, it depends on the application. But the first step in the journey, or maybe the second step in the journey, is really to have an application that is containerized. If we want to start a new development, basically nowadays, most probably you will start building some distributed architecture based on the microservices, and you will leverage containers to package and deploy your microservices. You will implement some DevOps practice, so to automate deployments, and some APIs. So and this all also could be followed by 12-factor approach. So again, you have heard about it, so I don't want to repeat here all the story again. And so we have a containerized application. We need a platform to run our application. So of course, in case of Red Hat, as I mentioned in the beginning, this is a OpenShift platform, which is based on the Kubernetes. Basically, it provides on top of Kubernetes all the tools to build, deploy, and run your applications. Quite important component from this discussion point of view, this presentation point of view, is service mesh, which I will talk about later, which basically allows us to build and manage the services, the communication between the services, microservices in our containerized application. But I will come back to that. So there is always quite often a question about what if I don't have containerized application? So for quite a long time, there was really no good answer for that. Now there is at least hope. There is a project called KubeVirt. The goal of this project is really to allow Kubernetes and OpenShift to be able to run and manage virtual machines, just like you can now run the containers. It is still under the development, but once this will be done, you might have a possibility to also use the same approach to components of your applications that are running in virtual machines. And actually, we have a number of customers, especially in telco, who are looking for this kind of platform. So it's very likely at some point it will be implemented. Okay, so let's talk first about the developer-oriented topics. So CI/CD, however, in our case, the federated option, because we need to deploy our app into multiple data centers. So the first approach we took, like in the beginning of this journey for us, so 5 years ago, was really to leverage the existing CI/CD tools. So, for example, Jenkins or anything you know. The modification in the pipelines was to really to create multiple endpoints where we used to push the images with the services, containerized services. This has been pretty easy. Here is some example of Jenkins pipeline. Also, at some point we started playing with Tekton, which is Kubernetes native CI/CD engine. So it's pretty new and fresh, but it also supports a concept of a cluster. So you might register multiple clusters, like here on the left-hand side, and then you can have a step in your pipeline where you deploy the image to one of the clusters. So you can repeat the same approach as before. But there is one major disadvantage of this approach, which is the fact that with that approach you have to deal in your pipelines with any problems or issues. So if we come back here, related to the parallel or sequential deployments of images to multiple registries. So in order our application to run, we need those images to be available in each of the clusters. So it is critically important to have a reliable way to distribute those images. And CI/CD engines are not the best tool to deal with problems that, for example, there is no connection at some point of time with one of the data centers, or there might be millions of other issues. And that's why we actually, fortunately for us, Red Hat introduced a platform, the Docker registry called Quay. So Quay has been available for quite some time. It has been developed by CoreOS, which has been acquired by Red Hat. And so this enterprise container registry has actually two very important functionalities for us. First one, which is important from this CI/CD point of view, is the ability to geo-replicate the Docker images. So with that solution, basically we can implement the process in the way that we have just one entry point for our images. So in our pipeline, we push images to only one of the endpoints or instances of our distributed registry, and the rest is handled by the registry itself. So it can geo-replicate the images of our application between different instances. And this has solved for us the problem of releasing new versions of the services based on the container images. But there was one more challenge here. So the challenge was, how do we deploy our application configuration between different data centers? So typically, when you create a new application, you build some configuration. So in Kubernetes world, it means that you create some YAML file that contains your deployment configs and many other components. So you have bunch of YAML file. But in this multi or hybrid cloud approach, you need that to get replicated between different instances of your cluster, and this is basically where we started to use the concept of GTOPs. So the idea of GTOPs is pretty straightforward. It's just what I said. So you keep in gitrepo a bunch of YAML files which hold the configuration of your application, and then you have an engine that could replicate that configuration between multiple clusters. So we've been using from quite early days Argo CD for that purpose. So with Argo, what we can do. So the workflow with Argo is pretty straightforward. So first we register multiple clusters. Then we synchronize GTOPs that contain our application configuration. We can create some overlays which are specific to some cluster configuration, because I know, for example, if you configure the ingress configuration or you will have some config map that holds the environment variables or some configuration file, they will be most probably different between the clusters. So you need to have some way to configure some cluster specific configuration, and this is where you could leverage here the overlays. Then, of course, the engine is capable to synchronize the configuration with all the cluster we want to, so it can send out the configuration to all clusters. And what is equally important, it can also monitor the configuration at the cluster, so that if there will be some drift detected, so if there will be some difference between the configuration that is stored in your JIT and versus what you have on the cluster, it will revert back to the JIT configuration. So this is a very nice engine to keep in sync all the configuration. So over the time, there was a concept of operators introduced in Kubernetes. So operators are kind of let's say advanced installers for Kubernetes applications. So they can basically hold and store all the configuration files, all the YAML files that are needed to deploy your application. This is something new we are starting to use. So we want to start using more operators and manage the with the GTOPs tool. We want to manage the deployment of the operators and configuration of the operators instead of configuring the plain application config files. And the future hopefully will be the kubefed. So kubefed is another project that is still under deployment, but once it will be finished, hopefully it will cover these two challenges. So both the central application configuration management as well as CI/CD, federated CI/CD. But again, this is still under development at the community. Now some topics related more to the infrastructure and operational part for the application. First one is networking. So here are the two topics that are typically the big challenge. The first one is how you allow the traffic coming to your application, which is deployed between different data center. So for that, we typically use Global Traffic Manager. Global Traffic Manager is a DNS server. So it doesn't really so the traffic do not flow through this GTM. It simply returns the IP addresses of one of load balancers that are running and that are accepting the traffic in data centers. In reality, this component is quite complicated, because what you will need here, you will need some health checks. So you need the GTM that supports health checks, so that it can check whether the specific application instance is up and running at the moment of client request. Also, okay, let's skip it. And the load balancer could be, typical load balancer that simply will be just act as a kind of proxy to your Kubernetes server, where you might have multiple worker nodes, so it might somehow distribute the traffic. The other important networking related aspect is related to service mesh. So service mesh based on the Istio is basically the way how you can centrally in the centralized way manage, connect, secure the communication between your services. That could be either microservices applications or maybe some more macro services applications. So this is the architecture. So you have a control plane where you configure everything, you monitor the platform, and then in your services you run additional container envoy proxies, so sidecar container, which is basically the policy enforcement point. So it will execute all the policies that you have defined. And in regards to multi-cluster deployment, you will, if you will rely on service mesh for your services communication, you will also need the multi-cluster deployment. And actually, Istio supports this kind of architecture, and you have three options to choose. First one is where you have like a replicated control plane. So it means that if you have multiple clusters, each of them will have a separate control plane and separate configuration. And this is typically the best way, the best scenario for multi-cloud solution where the networks are totally separate. So there's really no way to interconnect the service mesh the other way. So this will require for you to use a shared root CA. So the certificates that are used to authenticate, to authorize, must be issued by the same root CA. And also you need to deal yourself with the synchronization of the configuration. So if your instances of your service mesh should be identical, you probably will need again GTOPs to synchronize the configuration. There are two other options here. So where you might have just one shared control plane, and the difference between those two is that either you have a single network or you have multiple networks. So again, this means that either there is a common network, so you can connect these two meshes into one network, or they are totally separate. So in multi-cloud, typically you will not be able to have the same network. However, sometimes especially in hybrid cloud approach, you might be able to do that. This will require some low-level configuration of the tunnels. In case of OpenShift, this can be done on the operating system level. Another topic, data replication. So I think this is one of the most complex and difficult tasks. So in general, you have a couple of options to consider, and typically those options have to be considered on your application basis. So of course, the easiest way is to avoid replication of data. So actually, we are talking here about the situation where we want to have like multiple places that will serve the data. So we are not talking here about some API that will call some backend and will expose the data, but this is we are talking here about the data layer, so databases or some file servers that serves the data. So the base scenario is always to avoid the data replication. And there are three other options you can consider here. So the first one is the infrastructure-based replication. However, this again will probably not work in public cloud unless you have a solution, probably some software-based solution that will give you the possibility to replicate the data. But these are separate storage infrastructure with separate different technologies. So typically, it is not possible in multi-cloud scenario. So you have to rely on application-based synchronizations or replication. And again, there are two options. So either you have you replicate data between different data centers, or you partition your data so that one data center just stores some subset of your data. From our experience, what has worked really well here was the approach with the application-based replication. So this is the example of Red Hat single sign-on platform, which is the application that you can use to manage the access of users to your application. So this platform has a capability to authenticate, authorize the user, and to manage the user sessions. And there are two groups of data in this application. So we have user accounts, which are stored in a relational database. And we used to leverage quite successfully here a solution based on the Galera, so the MySQL database, multi-master database configuration. And the user session data, which, and by the way, the data in the database is not changing very frequently. So it will change when user will be created, will be modified, or will be removed. So in general, even if we used to have like millions of users, this was relatively not that huge amount of data. The much bigger amount of data was related to user sessions, and this is where we used to we have been using data grid. So data grid is in-memory data cache, but it has also a geo replication functionality. So it has quite nice protocol to replicate the data. This data can be also partitioned, so you can optimize the network configuration. And with that platform, we have been able to replicate user sessions so that when one of the site was gone for whatever reason, the user session was still stored in other site in the cache. So the user experience was not impacted by that event. Management. So again, the management of the platform, the PaaS platform basically, is first of all is about ability to automate the installation and the upgrades of the platform itself. And in OpenShift nowadays, we work, and basically this is also the same for other vendors on central We are working on a tool that allows you to manage in the central way your your clusters. So this tool is called Cluster Manager. So with that tool, you can basically install and upgrade multiple clusters deployed in different either public cloud or on-premise from the one central console. So currently, this is a software as a service platform, but we are also aiming at porting that platform to be on-premise platform. From the monitoring point of view, in OpenShift we rely on the, I would say now, very common stack. So Prometheus for storing the metrics, Prometheus Alert Manager for all the alerts, notifications, and Grafana for the visualization of our metrics. And because this stack is very easy to configure and run in each OpenShift cluster, our approach was typically to run central Grafana, which was accessing different Prometheus instances that were collecting metrics from different clusters. And then we used to build some multi-cluster dashboard where metrics from different clusters were visualized. And security. So security is something that is very complex and very important in OpenShift platform. So OpenShift out of the box comes with lots of built-in security features. So starting from the operating system layer, where you have SLinux, seccomp, namespaces, control group, all those things configured and running. Then we have, as an administrator, you have a possibility to configure permissions for users to run different pods. So you can specify kind of security context for pods, where you can define pods, so containers basically, where you can define what kind of system resources they can access, what kind of permissions they will have, how they will how and whether they can access networking and storage and so on. Then we have the networking layer. So in OpenShift, we use by default VXLAN-based SDN solution. So with that solution, you can configure network policies, or you can have namespace-based network segmentation. And then we have all the airbag-based configurations, where all the components, the namespaces, and access to monitoring, logging stack, they all are secured and managed by airbag out of the box. But what is missing, and what is still missing, is the support for any kind of multi-cluster security and compliance. So if that was the case for customers, we have started with Open Policy Agent project, which basically is kind of low-level policy enforcement platform. So it is implemented as an admission controller in Kubernetes. So it basically means that every API request is intercepted by this agent, and then it can verify the content of the API, Kubernetes API request, whether it is compliant or not with the policies you define. But this is pretty new project and quite immature still. Also has no support for multi-cluster configuration. So you might need to use solutions like GTOPs again to distribute the policy configuration between different clusters. However, there are a number of let's say more proprietary solutions available. One of them, which we use especially recently, is the IBM Cluster Manager, which has a multi-cluster manager, which has a compliance module that allows you to to manage in the centralized way the compliance policies that can be deployed and enforced across multiple clusters at once. But I think this is definitely the area of further development. Another very important aspect from the security point of view is the container image security. So in case of our platform, we leverage here the image scanning solution, which is part of our QA image registry. So the same which I mentioned before in regards to geo replication. It also has this built-in functionality, so that every image that is deployed into the cluster is or can be automatically scanned against some vulnerabilities that the libraries it has inside might have, and furthermore, OpenShift platform can block a deployment of image having this vulnerabilities. So as I mentioned before, the practice we have at Red Hat around hybrid and now also multi-cloud adoption is around for almost 5 years. So if your organization is looking for support and help in this kind of journey with the containerization and the Kubernetes-based solution, we are here to support you. And I think some links for you for reference to read a little more about the topics I touched, at least some of them. And that's all. Thank you very much for your attention. Here is my email.